In the last example, we saw whether they were equal or not. In this example, they're asking us to actually solve for x or figure out what x is. Well, if you remember from some examples that we did earlier, we figured out what do we have to multiply this number by to get this number. Well, with this, it's not as easy because we can't multiply something by 4 and get 17 easily. I mean, we can, but it just doesn't, it's not coming to mind as a multiple of 4, right? We know it's going to be some kind of a fractional answer. So what we can do is we can use that cross multiplication technique and set up an equation and solve this. So what we're going to do is we're going to multiply the 3 times 17 equals the 4 times x. So now 3 times 17, if we do that, that gives us 51 equals 4 times x. And then to get x alone, we would have to divide both sides by 4 to get x equals 51 over 4. Now 51, that can be reduced down because 51, I know that 3 will go into it, but 3 won't go into 4. The only factors of 4 are 1 and 4 and 2 times 2. So 2 won't go into 51. And will 4 go into 51? Not evenly. So this then would be our final answer. You do always want to check and see if you can reduce down your answers. But since we can't reduce this down any, that would just be our final answer. Alright, then we have example 8, which says for the fractions 2/3 and 5/9, we want to replace the comma. Okay, so we have 2/3 here and 5/9 here. We're going to replace that comma position with a correct symbol, either less than, equal to, or greater than, to make the statement true. Well, there are, again, different ways that you can look at this, but the easiest way would be to make those have a common denominator so that you could compare the numerators. So if I want to make a common denominator here, we always have to go up. We can't go down, because remember our doing the common denominators before, we're always multiplying by something. So what we could do is we could rewrite this 2/3 as something over 9, because we can multiply 3 times something to get 9, and that would be a 3, wouldn't it? So I can do the exact same thing to the top, and when I do that, 3 times 2 would be 6. So now I'm comparing 6/9 versus 5/9. And because the pieces are the same size now, the pie is cut into exactly the same number of slices. And would we have more if we had 6 of those or 5 of those? Well, that would definitely be, 6 would be the larger, right? So 2/3 is larger than 5/9. So if you can get them to be the same denominator, then you can compare the numerators. Alright, and then our last example here is arrange the fractions 11/14, 11/21, and 11/23 in decreasing order. So we want to know which one of these is bigger, and then write the next one, and then the smallest one last. Well, the only way that we can do that is if we have common denominators to be able to see exactly what it is that we're working with. So I'm going to rewrite these as 11/14 and 11/21 and 11/23, just so that I can spread them out and work with them. Okay, I know that 23 is a prime number. So we may want to start with that one. 23 times 2 would be 46, and that's not divisible by 21. See, 21 times 3 would be 69. That's not divisible by 21. 23 times 4 would be 92, and that's not divisible by 21. 23 times 5 would be 115, and that's not divisible by 21. So we're going to have to figure out our common denominator here, which might take us a little while. In this case, we may want to use the prime factor tree in order to be able to make it a little bit faster. So we know that 14, that would be 2 times 7, right? 21, that would be 3 times 7. And 23, that's just 1 and 23. It's prime. So remember, when we find our least common multiple, which is the same thing as the common denominator, least common multiple is the same thing. We know that in this scenario we have some 2's, we have some 3's, we have some 7's, and then we have 23. Remember, we go back then and look at what's the greatest number of times that each number appears in a factorization. Well, in this case, each one only appears once. So our least common denominator, or our least common multiple, would be 2 times 3 times 7 times 23, which would be 966. So that one might have been taking us a long time to find all the multiples of 23 and figure out which one went into it. So I'm going to rewrite these all as over 966. So now then, what do we have to multiply times 14 in order to get 966? 966 divided by 14 would be 69. So we have to do the same thing to the top. So 69 times 11 would be 759. So I can rewrite that fraction as 759 over 966. Now I'm going to do the same thing to this one. What do we have to multiply by 21 in order to get 966? And that would be 46. So if I multiply 46 times 11, that would be 506. And then finally, what do we have to multiply by 23 in order to get 966? And that would be 42. So we're going to do the same thing to the top and bottom. So 11 times 42 would be 462. Now that they are all over the same size pieces, we can look to see which one is the biggest, and then the next biggest, and then the smallest. And it just so happens that these are already in decreasing order, because the 759 is more than the 506, which is more than the 462. So to write these in decreasing order, we would say 11/14 is first, and then 11 over 21 is second, and then 11 over 23 is third. But we didn't know that until we could compare them evenly.